Okay, so just actually a few minutes ago, in part 1 of this refactoring primitive session code smell, we started to extract these seed objects, and actually this should have thrown some TypeScript error, I think, because it doesn't make any sense. So this is part 2. So we started in part 1. We handled the data for states case, and it's getting better. It's not awesome yet, but it's getting better. And now, so all our tests are still passing. But there is still this if-else for the blueprint case. The blueprint being the blueprint, the model, the original state that will be returned from the factory, original object that will be returned from the factory. And we still have to handle the case of, is it a function or is it a basic object? So how can we handle that? So let's see what happens. So right now, so these are the states, and at this point, this one is interesting. This is the starting state of the accumulator. So this is a reduce function. So it takes an original state, which is called the accumulator. Actually, maybe there is documentation. Reduce. Okay, so reduce looks like this. It takes a function that must return new accumulator, being not the name but something, right? And this function gets passed the accumulator, which is what you returned from this function the last time it was called, and the current value, right? Because reduce happens from an array. 1, 2. So if I always return the current plus the accumulator plus the current, the first time it will give me undefined. The second times it will give me undefined 1, and the third time undefined 1, 2. And that's why we want to avoid this undefined. I can initialize the accumulator with a value. So if I pass it an empty string or a, for example, I will get a, a1, a2, right? Actually, I will never get only a, I will start with a1, sorry. Okay, so that's the idea. And so I think we can use this initial value and pass it to blueprint, and I'm expecting that no, it still wouldn't pass with only this step, because there's also the override that we should apply. But I think this test will still pass if we just do well, if we just move this. Ooh, that's interesting. The clone deep should happen inside the seed for me. Do we have a test for that? Yes, we test that it is not the original object, meaning it is equal but not the original object. So yes, it checks that we clone. So good, I was disciplined. Let's check. Our test should fail. Yes, it does. Okay, good. So let's do that. So let's pass it the blueprint. And everything still pass, which makes sense because we are still executing all this. Okay. But now if I do this, I think the equality should fail, right? Because we do not clone anymore. And it does. Object is equality. We expect it not to be the same object, but it is. Okay. So that means that at this point, I think we should re-establish the cloned thing, and our tests should now work again. Okay, and it does. So we are moving the complexity to the object that it belongs to. So it's a bit better. Do we need this if-else now? I don't think so. Because, no, we don't. We already applied the blueprint. So we need to return the applied states with the overrides on top. Okay. That means that at this point, we have a seed, so we can merge from the overrides. And so we can return the applied states that, no, not value. And why are you complaining? Overrides. C. The partial T. Thing maker, where are you? So it has a problem with this. Okay. Yes. So because the overrides are of type T but might not be complete. So I'm going to struggle on this one, I'm telling you right now. But why didn't you complain for the states then? So you get a user seed, which is of type T, but a user seed might actually not return T. It might return a deep partial of T. Yes, I get that. the partial t is not assignable to type T. Yes. Let's try that. But I don't think it will work. The partial T. I think it will make more bad things than good. Yes. Or let me see. Maybe. Told you I was going to struggle on this one. No, can't work. No, sit that from T. So you get past override. Yeah, but no. Crap. But then again, because merge expected the same type of seed. So this is where the problem is. So maybe yes. Okay. So this is cool. We managed to work our way up the chain and find out where the problem was. But does it make sense? So you can merge a seed that is either the exact same type or partially the same type. Okay. But what if I pass the partial type already? Okay, let's see for now. Otherwise I'm going to burn my brain and make it explode without moving anything on and without solving anything. So I am going to push the code and see if there's a problem with it. So this is not very clear, I find. There's a ton less code. Let me see if I can go to my GitHub account. Try this factory and see the master. So you are inside source, index, and at this state, you should be good. Crap, this was before the refactor. Okay. Okay, yeah, fuck it, not going to pass the whole day on this. But we substantially reduced the code, so that is good, but this is not very explicit. And actually I expect that now, if I want to test that it works for the overrides too, I think it should work. So let me remove the state here. I don't want to apply it because it doesn't exist. And if I apply the seed as the override, I expect it to work. And it doesn't because I am not authorizing. Yep, I'm providing a deep partial, but when I should actually be providing a user seed. There are going to be trouble with this, because sometimes I don't provide the whole object. I think this is going to cause trouble, but let's see. User seed type T. What do you say? You say what I thought you would, that it causes problem. Can I do... Okay. Does it work? It seemed to work. So I basically did the same thing as I originally did. That is saying that what you get passed is a deep partial, meaning it might be the complete original object, but it might not. But it has the same keys. And what I'm saying, that this thing that might be complete or might not is a user seed, meaning it might be a basic object, or, which will then be this deep partial, or it might be a user dynamic seed, meaning a function that returns this maybe complete, maybe not object. And it works, so that's good. So, what can we change? Do we need to do that? States, clone deep states. I see the idea behind that, which is protecting the original values passed, but there's no need for that now because we already tackled that when we return the object. So I think you can get away. Oh yes, sure. And we still passed, that's good. So we can directly, don't allow me that, okay. We can directly return this, and it should pass. Okay. What else? So, states to apply. Names of states to apply. This is a bit verbose, but okay, fine. And all the tests are still passing. How much battery? Ooh, I'm short. So we take the name and map it. Okay, I'm actually going to extract that. Okay, this is one more loop, but really it does not matter. Like, I don't think you're going to provide 15 states, and even if you do, it's going to take nothing. So that's fine with me. And I think I'm going to separate the two steps. State from sim1 states equals this, and I will return sit with states. Ooh, come back. Thank you. Sit with states that merge. And you're not sit with states, you are blueprint states. I don't like the fact that the blueprint is hidden here. So I have two possibilities. Either I think I will do that. I will create an empty thing. Ooh. You either t or the partial of t. Don't like where this is going. So you return a seed of the type T that might be a user seed of the complete or partial object. Okay. I don't like that. I'm feeling dirty right now. So what's the problem? The problem is that I am trying to pass a not empty t, and this should be authorized. But that means that the seed that I return might be a seed of type T or partial T. Okay, so that means that I need to be able to merge a seed of type T of all the partial T. Okay. And I think this is here because the partials of the partials is weird. Okay, let me go back in time. So this is where things get ugly because user seed is of type T. Which it is. This one should be. But I think we should accept T or there's too much of those now. The partial, yeah, there are too much of those. Of type T. So you return a new seed. So actually the from might always be the partial of T, right? Okay, this is boring for you, I guess, and I don't have much more time. So for now, I am going to make the dirty thing, which I don't really like. But let's go with that. And I will go blueprint, which on top we will merge the right now it's named blueprint with the states, but it is not anymore. It is the merged states, to which we apply the overrides and then we return the value. Okay, that's a bit better because here we don't have the blueprint hidden. It's more explicit about what's really happening, right? We have we create a seed from the blueprint. On top of the blueprint, we merge the states. On top of those, we also merge the overrides. And we return the result of that. So that's better to me. I still don't like this part, but I think it will be so maybe I think there's an object inside of this, then maybe. What could it be? So and we still have to do it here, because if we do it over here, the state will already be computed and the results won't be different every time. I'm not sure I checked that, and I don't. Let's do that. And I will have to refactor my test to generate different data every time for states. So that means that at this point I expect it to be generated too, but I think it would fail if I pass it here. Why are you... oh, any... oh, sure. I have to first map the states. Okay, I don't have the time for that. I'm really sorry to end on this floating thingy. Okay, so let's fail this test for the next time we tackle it with a bit of a fresher brain to do. Okay, and I don't like the fact that I had to do that, so I am going to trash myself, or rather give myself a note. How come you are working now? Okay, this is suspicious, but we did something great. We extracted this value object, decided that for now the complexity of adding a dynamic seed, a simple seed, and a composite seed just to avoid this simple if-else was way too much, and that this was enough. We merged the factory here, and actually I think we can create a null seed for that. Seed that null seed using the null object pattern, which I really like. Static, I'm not sure. Null seed equals seed that from, and our test should still pass, and no it doesn't because I did that, and our tests are still passing. Good. So this is better, this is more explicit, I really like that. And yes, I re-enabled the fail here, so everything is failing now. But I think there's something to do about those, right? The mapping should happen here before. Yeah. Okay, no. I won't add a comment telling me what to do. Maybe I'll have a better idea when I come back to it with a fresh mind. But my guess is this mapping will happen here, which will allow me to separate in a more meaningful way the two parts here, because really this part doesn't belong in this make thing. We just have to merge the applied states together, right? Not to convert the state into a C. So that's one thing. And after that, I'll have to check this seed that from empty object that was failing when we tried it, but it's not anymore. I'm not sure why. And I think I have to improve my knowledge a bit of those generic type, because I am getting my brain on overload with those. Okay, so maybe there will be a part 3 then. So again, let me know what was useful, what wasn't. And subscribe, comment, like, everything. Thank you very much. And should I commit this? I don't think so. I broke everything. No, it's not broken. Let's commit this. I'm working alone, so it's fine to break my test, to leave these as to-dos. So what did we do? We refactored dynamic seed blueprint to value objects. There we go, let's push that. And we are done. Thank you very much.